So the next section deals with finding the equivalent circuit. So to find the equivalent circuit, we will be conducting three tests. One is the open circuit test, second one is the short circuit test, and third one is the DC resistance test. So with the open circuit test and short circuit test, you will be getting the synchronous impedance, because synchronous impedance is nothing but the open circuit voltage divided by short circuit current at constant field current, or at same field current kind of thing. And then with the DC resistance test, you'll be getting the armature resistance. So if you know the synchronous impedance and armature resistance, you can find the synchronous reactance. There is the relationship, you know that one from the basics. So we'll try to first conduct the open circuit test. So this is the circuit diagram you have to configure. So what I did from the previous step, these two connections and these connections are same, so I left it like this without removing. So I'll be connecting the wires for this. This is very simple thing. I'll quickly do this one. This is the field circuit and this is the armature circuit. So the armature is open, that's why the we call it open circuit test. So this voltmeter is only measuring, is a measuring device. It's connected to measure the open circuit voltage. Otherwise the machine is open circuit. The 1, 2, 3 terminals, they are open. Nothing, no load is connected to these the terminals. Okay, so let me quickly change the. So this is the complete setup. So I usually start from the power supply. So see this is the fixed DC power supply. So the fixed DC power supply, it's red terminal there. It's going to I3. So fixed DC is going to I3 here. From I3 outgoing, it's going to R here. So the R means this resistor load will be using, and maybe we have to use a little bit longer wire. That should be fine. So this R we are using in order to change the field current. So this one is going to number 7, again red terminal. Number 7 is here, from here to here, and from 8, so this one is connected here. From 8 it's going to power supply. From 8 it's black terminal, so it goes to power supply. Yeah, okay, got it. So this is the field circuits going to I3, go to R, and we'll turn on both the switches. That way all the 9 resistors in parallel, and we have got a choice to figure out these things. You can notice that the field current can be varied by using this and this. So this is just why, because we have a fixed resistance, we can like in steps wise or a course control, we can have the field current. And here, because it's a smooth variation of the resistance, here there is a pot and the number of turns there, we change the knob there, so that would be the field current changes smoothly there. So I will show you in a moment when we do the experiment. So this is for the field, this is for the smooth variation, this is for the coarse variation, means like in more discrete, more steps kind of thing. So that is the field here. And for the synchronous generator, the Y connection, the connection is there made, and the other, and we need to connect a voltmeter there. One is the red terminal, so we will connect to the red terminal, so we can use the short terminal there. It may reach, yeah, it's not reaching, so that's Okay, so we'll use this one here, voltmeter, and the other one will be using the white color wire. So white color wire will be using this one. So basically the voltmeter is connected across the one winding here. So that is the one winding here. Okay, so let me go back to the instructions and show you what is the next step. So once I'm done with the circuit, so just on the resistive load, make sure all the individual branches are off, and both turn on both yellow switches. I did it to make it all in parallel. And then on the synchronous generator, set the exciter switch to one position. It's already there and should be in minimum position, so I will set it to minimum position. Okay, I set that one. And then on the metering window, keep meter I1, I3 and speed. So we want to measure the open circuit voltage with respect to the field current, and we maintain speed constant, I guess. That's why. So we go to metering window, this one, E1, I3 speed. So the remaining things we can just that is the voltage, field, speed. So we don't need this one also. Okay, what is the next step? Data table window, same thing. We need to measure the field, the voltage, field current and speed. So we'll just change the settings here, change the options, record settings, metering window, E1, I3 and speed. That's it. So we don't need anything else, only 3. So you can see E1, I3, speed we need, so that is not there now. And then what else we need to do? So leave the first row blank. So we'll leave the first row blank. So and then lab and state verification, that I already did it. Run the machine at 18 RPM. So on the power supply, turn on the power, and then turn the voltage control knob to run the generator at 18 RPM kind of thing. And remember to maintain the speed constant. So when you are changing the field, the speed has to be maintained constant. Only one variable to be changing, the other variable to be kept constant for proper gathering of the data. So for overheating, so keep an eye on the exciter knob. It says, I will keep that one in mind. Record the data with increase in. So this is the step we are doing on the synchronous generator. Set the exciter switch on position is already there. Starting from left, turn on one resistor. Check the speed. If the speed is dropped, adjust it to 18 RPM. Once adjusted, record the data. Repeat the steps until all 9 resistors are on. Okay, so we'll do that one. And once all the resistors are on, since we need more data points, so while the machine is running, take a short wire and bypass the resistor by connecting the wire between the top and bottom terminals. And then by turning on the exciter knob, continue to increase the field current in steps of 100 until maximum position is reached. So in each step we will be adjusting the speed and recording the data. So that step I will be doing, and then turning off the power, saving, and then graph. So let me show you these steps, how to do that one. That's it, I guess, for the open circuit test. So let me go back to the thing here. So let's power down. So this is the thing. So I'll keep this one on. So hopefully I remember all the steps. Go to this one. Everything is 0. So this is the complete setup there. And This one I turned on these two yellow switches, turned off all of them, and the switch is on position, that is at minimum position there, that is exciter knob there, and then that is 0 off. So we'll turn on the power and see what is happening. So 1000 RPM we have to set first. So it's 1000 RPM. So the close 1008, 1800 9 RPM. So 1805 showing here. So I will just we'll leave it there, maybe 1008 showing there, and you can see there is a small even though there is no field current here, field current no field current because of this no resistance on there. So there is small voltage there. This is because of the residual flux. That means we were running the machine for some time, because we are passing the flux, the magnetic material. Remember, some flux retains there. It's called residual flux. That is one of the questions in the report, which may be helpful. Okay, so I will just record it there. Okay, and then we'll try to maintain. So we just add the resistance there, and see the speed is changing a little bit. So I will just adjust it to 18 RPM, and then I'll take the recording there. So basically the field current is changing here. So I will take the next one and check the speed is not much change. So I will just take the reading there. And the next one is this one. So that is there, and speed is a little bit changed. So I will just adjust it. And then I will take the reading. Next one is this one not much change, so I will take the reading again. And next one I'll operate it, so there is no much change in speed, so I'll just record it. And next one is this one, there is no much change in speed, I'll record it. So the reason why this speed is not changing, there is no power is given. The machine is running the open circuit, just in the inducing the producing the voltage, but no power is transferred to the electrical wire, so load kind of thing. So they take the reading. So take the reading. So next one is and this there is no speed there, and I will take the reading there. Next one, no change in speed, and take the reading there. Since all the resistors are now done and the current is 0.36, so I want it to increase more. So what I will do, I will just short it as per the instructions. Just short these to top and bottom terminals. Now, so this control is over, done, bypass. Now we have only one this control, so we can change to 100 milliamps. 0.36 was there before, and 0.42 is the next one. So I will just take the reading. And speed is not changing much, so I will take the reading now. And then I will change to 100, maybe 525. I will change it. 525. 100 meters in steps up, and 100 milliamps we have to make it. So 525 and 6 are fine. Speed is not much change, so I will just change it. and then take the reading, and then field 525 make it. It's 20, okay, 25, it's 28, leave it there, that's fine. It will not change much, so I will take the reading, and then I will do the next one. 725 set it. 725, 728, that's fine. So speed will not change much, so I will just take the reading, and I think we are coming to close to 827. Yeah, okay. So speed is still not changed, so I will take the reading, and then maybe that maximum value is 0.820, same thing. So not, so I'll take the reading again. Yeah, so now since I can't keep a long time like this, so I will make it point minimum there, and then I will turn off the power, reduce the voltage to 0, and turn off the power, and so we can focus now the data now here. So this is the data we got now. So we changed this field current from 0 to 0.8182, so it got a little bit decreased, but that is fine. So, and you can see the voltage change from 2.4 to 132. So this basically, and we kept the speed more or less constant here, and we'll try to draw a graph, I guess. So I will, what is the next step? So we'll check, we kept the speed constant, turned off the power, saving. I will just save this one and come back to you. So this is the data I posted there in the data template, and the next step is to draw a graph between the output voltage and the flux, I guess, field current, I guess. So that is the field current, yeah, next y x-axis. So x-axis I3 is the field current, and this is the, so this is just like a open circuit test, just like you did the open circuit test in transformer. This is the open circuit. This is like a magnetization characteristics also we can call. So it's like I think saturation test results. So linearly it will change here, and after some time it's bending it. If we further go, so what happens, the voltage gets saturated and the no more change in the output voltage, even though the flux is changing. That's what you will notice there. So I will just keep this one and come back to you. So I posted the open circuit characteristics here, and the next one is just doing the short circuit test. So I think we may be able to finish this all the three tests in one video. So let me quickly do this one for you. So this is this circuit diagram we will be connecting. So I'll quickly show the field, and then we'll make the connections. So from the previous circuit, some connections I kept on to save the time. So only thing is we have to make these connections, the output side short circuit. So we have to short circuit these two, terminal 3 and terminal 2 with yellow wire, and we need an ammeter there. So ammeter, and then red wire maybe. So from here it goes to ammeter here I1, and then from there it's going to, oh, this is too long wire, maybe need to be short medium wire at least. So this one should be connected here. So basically this winding 1 and 2 terminal is shorted through ammeter offers very low resistance there. So that is the circuit setup here, and then verification is already done, and then running the machine at 1000 rpm again, and will maintain the speed constant. And we had to do it very quickly, this one, because short circuit test, and overheating will also check it's not that much overheated. So we'll maintain the speed constant. So we'll set the resistance to 1200 first and take the recording, and then just speed, and you have to take the remaining things kind of. So we'll be using, I think, only one section there. So I will turn off these two yellow switches. So okay, and then we'll do the things, and saving the data and plotting the graph and running the connections. I will quickly go to this one. Where is that? Here. Okay, so right now it's 0, so we have to activate this one. I1 we are measuring short circuit current, that is that's there. Field current will run the machine at 1800 rpm fast. You can see that the speed is increasing. It's increasing. We have set 1800, so it's 1800 rpm here. So 1800 rpm, so there is no. So we just take the reading at null at this current without any field. We get that one, and then we first set 1200. Speed is not changing much, and then I will take the reading. Next one is 400. Okay, so speed is changed a little bit, so quickly adjust it to 1800 rpm, and then take the reading. And next one is 300. So 300, so we speed is changed a little bit. I will just quickly change this speed, and then take the reading. And the next one is 200, and 300 parallel. Speed is changed a little bit, so I will just quickly change it and take the reading. And then all the resistance 171 ohm reading, and speed is changed a little bit. I will just quickly adjust it, and then I'll take the reading there. So since it's an open circuit test, I don't want to leave it on for a long time. So I'll just so that is how we need to do the experiment. If you are here, let me focus the window and show you. So that is the data we have. So short circuit current is changing. So it's 0.3, but we exceeded 0.9. We went there. That's why you don't want to keep it. And field current we changed here. For speed we maintained constant here. So I'll quickly copy and I think maybe I'll show you the I3 field current and short circuit current. So it's linearly it's changing. It's a short circuit curve graph would be looking like this. I will show you in a moment the data and graph in the template. So this is the data I recorded here, and that is the graph here. So maybe we'll go to the next step there. We'll remove all connections. So DC resistance test also we can finish it in this video. So let me remove the connections and come back to you. So in the DC resistance part, so the initial conditions we had to know the armature winding current rating. The winding current rating is 1 ampere. I think I already noted here. So 1 ampere there, and then and we need to set the meter C1 I1 to DC because it's DC test. We have to set the DC. This is activate, and then no more these things. We need only these things. And then what is the next step? Set up this is very simple circuit. This is a kid circuit I call. It's very simple in nature. Let me focus. So in this we are using variable power supply. So variable power supply 7, from 7 it goes to I1. Oh, yeah, that's good. From I1 outgoing, it's going to armature winding terminal. So that is 1. Yeah, I'll leave it there. I don't have time to change the wires. So the next one is going to the 4. From number 4 it's going to this one. So it is not reachable. Yeah, it's reachable there. And then voltmeter will be connecting. So either you can connect here, same thing. So I will just connect here to avoid our stretching, and then we'll use the another thing. Will it work? No. So change the wire to medium black. So from here it goes to even. So basically, so from power supply 7 it's going to I1 to measure the current. It's going through the winding. It's coming back to this one, and this is the voltmeter is connected there. And what is the next step? So the verification is very simple. So we'll turn on the power, slowly turn the voltage control knob until the rated current. You know the rated current is 1 ampere. So we'll measure it and record it. That's it, I guess. So let's go. Let's do it quickly. So we don't need this one. No. So we need only this. So turn on. You can see that the current is changing fast as I increase it. So you have to be very careful. So while watching, this should be 1 ampere here. So 1 amp, 0.75, 0.81. So I'm at near to 10 percentage of the dial, but still about 86% is that's why you have to be very careful. You don't go to 100 and kill the winding. So this is 1 ampere here. So and then it's passing applying 12.64 volts. So I will take the reading. So I will just freeze it, and then I'll turn it off that way. So I will not passing too much current for a long time there. So let me focus the. So in a closer look, you can see that 1 ampere we are passing and 12.66 volts we applied. And I think to show you our knob position, it was, I think I reduced to 0. That is fine. So I'm trying to do everything fast. Sorry for that. That's why. Okay, so let me. So I copied these values into to the template, and then you'll be calculating the values based on this one. And I think powering down template learn. I think if you are here, you will be uploading the template. That's done, and I'll be winding the things. I think there's an insight here for the generator. Just you can read yourself this quote. Maybe it's useful. I think we are done with the lab. Thank you very much for your patient watching, and I hope you learned something with this experiment. Okay, see you in the next lab. Have a nice day.